Warm-up, number one. So we have a piecewise function. Oh, highlight. There we go. We have a piecewise function at 1 being less than, we have this, and then 1 at 1 and greater than 1, we have this function. Thou find the points of discontinuity and name the type of discontinuity. And then for number 2, particle moves along, blah, blah, blah. If you have a little function, you can read the problem. Is a particle increasing or decreasing at t equals 2? Is a particle speeding up or slowing down at t equals 2? So, go ahead and pause the video, try these problems, and then we can go over them. For the first one, when we plug in 1, we end up getting negative 3. Come on. We end up getting negative 3. When you plug in 1 for the second one, we end up getting 3. So, that is a type of discontinuity, since we have different y values, and they're both continuous by themselves. That will be a step discontinuity. So, find the points of discontinuity. That would be 1, because at 1, that's when we ended up, we plugged in 1 to get these. And name the type would be step. A particle moves along a horizontal line. Come on. I actually have to read it now. Its position function is in meters and t seconds for t being greater. That's just a position function. Is a particle increasing or decreasing at t equals 2? Oh, how do we find out? Let's find its derivative. Alrighty, so we have the derivative right here. Took the derivative, and let me highlight it. And we want to find out when it's 0. So first I factor it. So two numbers to multiply give you 3 times 100, which is 300. But add up to give you negative 40 is negative 30 and negative 10. And that gives you x minus 30, x minus 10. But of course you have to adjust for the fact that this had a 3 up front. So we want to divide by 3 divided by 3. That ends up giving you x minus 10. And then this thing doesn't really go into 10, which means that this is going to be 3x minus 10. That's kind of how I factor these. So the two numbers that are interesting is positive 10, because that will make that 0, and positive 10 over 3, or 3.33. That's when it's 0. Now we want to know if the particle is increasing or decreasing at 2. So we have negative infinity all the way up to 3.3. Should probably do like, which goes all the way up to 10, which goes all the way up to infinity. So these are the regions that we have to worry about. So the one that I'm interested in is this region right here. What happens right there? So when I plug in 2, then I would get 3, and then times 4, because 2 squared is 4, minus 80, because negative 40 times 2 is 80, plus 100. That would give you definitely a positive value, which means that in this region where this is included, that's positive, it's increasing. Now, just granted, we didn't need to do any of this. You could have simply just plugged in 2 into the derivative and gotten it, but I want to show you how to find the regions. And then it's asking, what's the particle speed? Is the particle speeding up or slowing down? That's when we want to know if you have a positive and negative acceleration, you want to take the second derivative. So take the second derivative. So our acceleration at 2 would be negative 28 meters per second squared. Since we had a positive velocity, this is going to be a positive velocity in meters per second, but we have a negative acceleration, that will be a slowing down. We talked about it in the past. When the velocity and acceleration both have the opposite signs, then that's a slowdown. If a velocity and acceleration have the same sign, that would be speeding up. So that being said, what is it doing? It's slowing down. Because the velocity, the acceleration, the second derivative is negative, but the first derivative is positive. So what are we doing today? We're learning about the chain rule. Students will apply the chain rule, blah, 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 blah. So what's the chain rule? Here's a definition. In the previous video, we were interested in creating 2 functions out of one single function. So we took a single function and then we kind of said, okay, that's the same thing as having a function inside of a function, so we identified the inside function, the outside function. Well, what happens is when you do that, the derivative will be the derivative of the outside function times the derivative of the inside function. So let's try some of these out. So if you were to look at, and right now this is all reiterating what we just talked about, if you would look at the derivative of a sine of u, then that would be the outside function, would be cosine of u, the derivative of the outside function, or the derivative of sine. But then you have to multiply by the derivative of whatever is inside sine. So we kind of call that function u, so that would be u prime. And same thing with cosine, we would have the derivative of the outside function, which is negative sine, and the derivative of the inside function, which is u prime. So here's an example. We have this derivative right here. The outside function will be x squared. So you would take the 2, bring it up top, which we did right here. And then we would multiply by the derivative of inside function, which would be, by the way, there's one right there. The derivative of the inside function will be 3x squared. And that's why we multiplied by 3x squared. So we took the derivative of x squared, which is just simply 2x. And then we put in here the derivative of the inside, which is 3x squared, giving you 2 times, and then x cubed plus 7, because remember that was the x part, times 3x squared. So once you multiply this with this, and then with this, you end up with this bad boy right here. Alrighty, find the derivative of sine of x to the 5th power. So the derivative of sine is cosine. So we have cosine of x to the 5th, and then multiply by the derivative from the inside, which is 5x to the 4th, and we end up with this. Over here, we identified that the outside function will be x to the 4th, so which would give you 4x to the 3rd, and inside 4x to the 3rd, that was a cosine, so we're not going to disrespect that. And we got to multiply by the derivative from the inside. The derivative of cosine will be negative sine. So we multiply them together, we get this. This one looks a little bit more complicated because it seems like we have to do this several times. Because the outside function of cosine to the 4th of 7x is x to the 4th. Inside is cosine of 7x, but that still has a chain rule in itself because the outside of that is just cosine of 7x and the inside will be 7x. So we have to do this several times. So let's do that. Yes, let's use a different color. The derivative of x to the 4th would simply be 4x to the 3rd. Keep the inside the same. Multiply by the derivative of the inside. Now that's going to be a little bit complicated because let's just use blue now. The derivative of the outside function, which is cosine, is negative sine, but we're going to keep that inside the same. Then we're going to multiply by the inside of that function, which is the derivative of that would be 7. So that's why we have 7 right here. You multiply all of these together, we end up getting this right here. So this will be a chain rule within a chain rule. Alrighty, so I'll go ahead and try these out right here. Pause the video and give it a try. Alright, derivative of sine is, cosine is negative sine of 3x. And then we multiply by the derivative of an inside, which is just 3. So negative 3 sine of 3x. Over here, the derivative of the outside function is 3x squared, but the inside is still a cosine. Then we multiply by the derivative of the inside, which is negative sine of x. So we end up with negative 3 cosine squared, and then sine of x. Sorry about the handwriting, it's horrible. And then for the next one, it will be 6 sine of x to the 5th, but then we have to multiply. The outside function will be x to the 6th. Then we multiply by the inside derivative, which is cosine of x. And the last one would be this right here. We have negative 6, which doesn't matter. We're just going to write it again. But then the derivative of the outside function would be cosine the derivative of sinus cosine of 3x, but then multiply by the derivative of the inside, which is just 3. So multiply 3 by -6, giving you -18 cosine of 3x.